I want to show some useful features of the parallel plot, and so I'm going to do this and talk about how we can use the parallel plot to be able to find rules, if the rules exist in your data, to be able to let you mutually exclusively divide categories of observations. So here we have the parallel plot, and when you first invoke the parallel plot on a data set that's got a number of observations, it's a little overwhelming at first. One of the best things you can do is get rid of things that are really not useful and reorganize the data set so that it helps your eye be able to see what's really important. Now, in our data set, we're not caring about area name, so I'm going to go ahead and hide area, since area is not really useful. So I'll click on this line and say hide area name, and that disappears. Now, everything being the same color is not helpful either, and we also have a region name, and we're trying to figure out different levels of acids that can help us determine which olive oil comes from which region. And that way, if we know, if we can sample the acidic level in the olive oil, we can just tell where it came from, whether it's from the North, South, or Sardinia regions. So I moved region name over here so that it's over to the far right, and now I want to start using different colors to be able to help us with our finding of rules. The way we can do that is by adding filters and then lassoing specific regions, and that way we can get them to turn different colors. And as I lasso these, we can get color to help us. Now in this case where we're trying to find mutually exclusive rules, our eye first falls over here to icosanoic acid, and it's basically very clear here that there is a region here where if this acid level is 10 or above, then it is south, and so it's red and it's south, and then these are around 4. So our first rule would be if an acid level is above 4, then it is south, and so that's going to help us identify these. And so now that we have a rule that can separate out south, I'm going to hide all the south observations and look to see what other columns we can use to be able to identify mutually exclusive rules. This isn't going to help us because for this particular acid, they're all very, very low, and so that's not going to help us. And so it helped us figure out what was south versus not south, but it's not going to help us separate out Sardinia from north. And so we can go ahead and just hide this and remove it from our analysis. Now, if you look here, you can see that we have blue and green overlapping, and we can see on a variety of these things where it is overlapping. So those aren't going to give us any mutually exclusive rules. The same thing's happening here. We've got blue and green overlapping, so we'll remove that. And steric is also overlapping. That's not going to help us, so we'll hide that. And we're making our plots simpler and simpler until we can find something that is not overlapping. This one is overlapping, so we're moving it. If we look at this carefully, what we see is that linoleic acid does seem to be mutually exclusive. All greens seem to be below here, all blue is above here. If we look at oleic acid, it's mostly the case. Most of the greens up here and most of the blues down here, but there are some overlapping. In fact, I can see, it's a little subtle, but you can see this green line going right down in here. You can see a line falling down here, and so there is some overlap. So this is not perfect, but it is helpful. There are regions that are mutually exclusive, but I'm looking for perfect exclusion if I can find it, and linoleic is actually doing it. Our arachitic is the same thing. It's usually pretty good, but we do have some green and blue overlapping, so we'll go ahead and remove that. Once we've removed all the ones that are not mutually exclusive, then our eye can see that, do a good job of seeing what the rules might be. We have to mouse over, we have to use our arrows to actually go in and do this. Now in the reading it says use your sliders to be able to make your rules, and so I want to show you how that is done. You'll notice that the blue is on top of the green. And so blue is also on top in the diagram. Now, what isn't visible, but I'm going to show to you right now, is that behind there is also the green slider. So we actually have a slider set for every single color or every single filter in our diagram. So if we want to use the green filter now to be able to slider to be able to filter out observations, we can move it up until all the green disappear and see where it does disappear. And as you move the slider, you can actually see the values change. So as soon as we get up to 1050, then all the greens are gone. And we wouldn't have known that was possible without that slider. And so there's our second rule right there. If linoleic is 1050 or less, then it's north. Otherwise, it is Sardinia. Now, we could have also done the very same thing with the blue slider. We could have come down here and figured out where blue disappears. And you'll notice that blue disappears. The last blue observation seems to be around 1058. And so there's pure separation between 1050 and 1058. There are no observations at all. And so we could have done it either way. And that's how you can use your sliders and your filters and hide stuff so it's not overwhelming to you in your parallel plot. If you want to bring some of these attributes or these fills back, you can just click on them and bring them back. Another thing you can do is you can show means. In the case of trying to find mutually exclusive rules, means do not help you a lot because you don't know if you have blue observations down here and blue observations up here, the mean is here. The mean is higher than the green observations, but you don't know if they're mutually exclusive. But if you just want to find the general trend, remember I said that when you summarize information, you also hide or lose information, and so that's what's going on in this case. But it is nice to know that you can use show means as an option to be able to do that, and then we can turn those back off.